Ethereum. It's one of the biggest. It's the second biggest cryptocurrency in circulation, actually. And it is one of the blockchains that you would actually see that the Bored Ape Yacht Club, if you've ever seen the little monkeys that are worth about 1 million or more, sometimes hundreds of thousands, or you've seen CryptoPunk, they're worth a ton of money right now. They are built on the Ethereum network. Ethereum is not only a blockchain, but is an asset. I mean, you can invest in Ethereum just like you would invest in gold, silver, wheat, oil, whatever. The current price of Ethereum right now is a little over 2,000, if I'm not mistaken. No, it is 1,631 right now. But of course, when investing in cryptocurrencies, you do not have to invest in it as a whole. You don't have to buy one whole Ethereum. You can buy it fractionally. So Ethereum is open, public and permissionless platform like Bitcoin, meaning you can actually hop on the internet, type up Ethereum right now, and there is a way called Etherscan. You can see every transaction that is being ran on the Ethereum network. So everyone who is transacting and sending money on Ethereum, you could actually see how much is being sent. It'll be denominated in Ethereum and not in dollar value, but you can always just correlate that out. So Ethereum was proposed in late 2013 by Vitalik Buterin. Cool guy, very smart. I think he's like 24, 25. After a pre-sale to fund development in 2014, the network went live on July 30th, 2015. It was described as a revolutionary new platform for decentralized applications, and it supports anything from voting, financial exchanges, to smart property. It's a standardized foundation platform, with enhanced programming, abstractions, protocol network. It's like super intense stuff, but very valuable to check out. So an object-oriented programming language called Solidity to facilitate the creation of distributed, decentralized applications and smart contracts. Smart contracts are contracts that are able to execute without human intervention. So let's say we wanted someone to send X amount of money every time this event happens. So every time that someone clicked on a website, we wanted $1 to be sent to this location. It would be able to operate by being programmed that way, and no one would ever again have to intervene for it to continue running that way. It would stay that way forever, and they're actually kind of hard to shut down. Developers are really the geniuses of the system because they're able to go in and set all these things up. And so teach your people how to code. If you know how to code, you are going to be set for life because you're able to build on the internet, which is always growing. So besides validation and distributed storage enhanced by Bitcoin, Ethereum also enhances processing of data and logic. It has its own native currency called Ether, as we were just discussing. With Ethereum's Genesis block in 2015, and the first block that was mined, 72 million Ether were generated. So currently, there's a little over 117 million Ethereum in circulation. You can think of it just like how dollar bills are in circulation. But it is not capped, just like fiat money. Most fiat money, like dollar bills, like if more needs to be made, it can be made. Unlike Bitcoin, which has a total supply of 21 million, and only 21 million Bitcoin will ever be in circulation, which is why it is so valuable right now. Bitcoin is currently floating at 21,000, which is on sale because it was like 60,000 last year, close around this time, if I'm not mistaken. So Ethereum's block time is presently around 13 seconds, but it can vary, meaning that the amount of time it takes for a transaction to go through on Ethereum is about 13 seconds. Some blockchains are much faster, and it's near instantaneous, meaning like a second or half of a second it can go through. Some blockchains like Bitcoin, it actually takes about 10 minutes, but the Lightning Network built on top of Bitcoin, it can take up to about 5 minutes, so it can run through much faster. Ethereum nodes, a node is a computer, but in the blockchain world, we call them nodes, and they're used to validate the transactions that happen on the blockchain. So they must validate and process more information rather than just payments. And until June 2020, Ethereum's block size averaged less than 30 kilobytes, and now it currently exceeds 70 kilobytes, which is barely anything. It's not even a megabyte, if you know how data storage works. I'm gonna skip all that. So smart contracts. Ethereum is based on the concept of self-executing smart contracts. They're really cool. So a smart contract in the context of Ethereum consists of immutable computer programs that run deterministically. So immutable meaning that it can't be changed. Once it is set in place and it's running, it is nearly impossible to go back and change what was put in place. So I compare it to having a ledger of receipts. So let's say you go and buy something at the store, and every time you bought something at the store, it was recorded online. Um, After a while, it would be hard if you made a mistake on. So say someone made a mistake on how much it cost for an item, and you overpaid or underpaid. They could go back and change that if they needed to. But if it was immutable, then that means that over a certain amount of time, it's not able to be changed, no matter if it was a mistake or not. It's like that with the Ethereum network and smart contracts. Once they're set and they're executing, it's hard to go back and change it. So a smart contract is an account containing code that executes whenever it receives a transaction from another account. So when X happens and Y happens after, then we will get Z to happen. So smart contracts may provide several advantages. For instance, they automatically enforce power equality to all parties involved. No one party is going to have more power than the other one. They protect the rights of the individual by enforcing reasonable expectations for the people who are signing. They eliminate the possibility of any signatory defaults on their obligations, meaning that it is set and run up by code, and code is agnostic. It does not vote for one party or the other. It's just doing what it's programmed to do. But there are also challenges in this, and that the legality and whether smart contracts are admissible at court, because people do some shady stuff on the blockchain, of course, because of the anonymous nature of it, and sometimes smart contracts are set up to do things that are not in the best interest of individuals, and it's hard to blame a smart contract for doing something that was just programmed to do, whether it's shady or not. We're going to get into open, public, and permission blockchains. There are a lot of different blockchains. Their types. Some of them are open, meaning that they're accessible to anyone. You can hop on the internet right now and see it, and anyone can do anything on it. Public, meaning it's open to the public, and permission, meaning only a few people can see it, such as people at the enterprise level, banks, government entities, etc. So in a permission blockchain, not anyone can join the network, as I was just speaking on. It's provided to certain identifiable participants to join the network, so they have to be generally KYC'd, which is know your customer. They have to submit ID or things like that. Whereas in other blockchains, you don't have to do any of that. You can be 100% anonymous and participate. So the requirement of being verified adds another level of security in case things go wrong and people are doing things in their own interest, or trying to attempt malicious acts on the network. So participants are known to each other and are trusted parties. So it's like if, so say if we want to start up a blockchain right now, or if you want to start up a blockchain with your family, everyone in your family knows each other, so it's a permission blockchain, and everyone outside of it cannot join unless they were validated through some means you had in place. Whereas with the open blockchain, if you wanted to create a blockchain within your city, then everyone in the city could access it, or anyone outside the city could access it because it was open and public. And they don't even have to show ID or validate themselves. It's kind of just like how the internet works. You can be on the internet and have a whole other moniker and never show your face and still create a name for yourself or do whatever else you chose. Same thing on the blockchain. So permission blockchains may also define the role of each participant, like who can operate a node, a computer, who can validate new transactions to make sure that things are true to the transaction, which part of the network and blockchain a participant can access or have influence over, and who can introduce changes to the system. Whereas in open blockchains, anyone who has the nodes or the mining power can operate, vote on decisions that are made, and things like that. This is what makes it a decentralized system. Everyone is able to access it, and they're able to vote on the decisions that happen with the blockchain. But it takes 51% of the individuals who are operating on the network to be in consensus and agree that they want a change to happen before it does. Ripple, if you ever heard of XRP, is one of those permission blockchains. They're currently in a case right now with the SEC. The SEC is suing them because they are saying that XRP or Ripple is an unregistered security and it's been listed by exchanges. A lot of people lost a bag on XRP. I lost a small bag on XRP. It was a couple of cents, and we invested in it because we saw the value in it at the enterprise level, and it just did not pan out because all of a sudden the SEC sued and the value of it shot down because people thought it was over from there. So it's not a good time. We're going to talk about enterprise, hybrid, and blockchain inspired blockchains, which is really cool. And then I'm going to be closing it up. That'll be it. So consortium blockchains are used by organizations or businesses wishing to process private transactions within a permissioned group of known participants between organizations and geographic locations. Like Hyperledger, it's an umbrella project of the Linux Foundation. If you're familiar with Linux, it's like Mac. Corda, so it's blockchain inspired, and it's a distributed ledger, meaning that a ledger is a record of transactions. So it's distributed amongst however many individuals they have operating on it. You're able to see transactions built on it. And then there's Quorum, which is a permissioned copy of Ethereum by JP Morgan. If you're not familiar with JP Morgan, they're one of the biggest hedge funds in the world. They hold billions of dollars in assets. The Enterprise Ethereum Alliance is a consortium which aims at creating a standard version of the Ethereum software for enterprise applications. So they have, Ethereum itself has a whole organization that helps run everything. There's hybrid blockchains. Hybrid blockchains combine elements from public and private blockchains, like Dragon chains, focus on interoperability in a multi-chain network of blockchains. There are 359 million Dragon coins in circulation out of a total supply of 434 million. And as of October 28, 2021, the market capitalization is 53.6 million. Meaning there are people making money off of this stuff. You just have to know what you're doing. You have to know where to look. You can go on the phone. There are others like IOTA, Tangle. IOTA is Internet of Things Accessible, if I'm not mistaken, and it's a directed acyclic graph, which is DAG, and it's a type of distributed ledger and not a blockchain. It's very different, but it runs similar to the blockchain that we're used to. Blockchain types, as of May 2019, it was estimated that there are over 800 blockchains, but the number is growing rapidly. Aside from those already mentioned, there is Stellar, Neo, EOS, there's Dash, Tron, Polkadot. There's way too many blockchains to sit and count. And there are new ones popping up every day as individuals introduce them, such as there was a cryptocurrency that Facebook or Meta tried to introduce. It was a failed project, a quote unquote failed project, and they currently just launched it as a blockchain to compete against Solana, which is one of the fastest blockchains up there right now. You can process the most transactions, and it is currently around $37, if I'm not mistaken. And it is called Aptos. So if you ever get the chance, look into Aptos. It's really cheap right now. I think it's like $6 or $7 for one Aptos. And they are supposed to be the Solana killer. Definitely a coin to check out. If you get in early enough, you might make a bag. How many blockchains are there? Blockchains may be used to support organizations in multiple ways, rather than just serve as a peer-to-peer payment mechanism. That's generally what blockchains are used for, is to send and receive money from one individual to another across the world near instantaneously. So I could send 1K to someone in Guatemala right now, as long as they have a wallet, a crypto wallet. Blockchains have presently evolved from the internet of money to the internet of value. So people generally live on the internet. So, I mean, it makes sense that it would have its own money, right? Own money, own value, and own system of assets. So aside of Bitcoin and Ethereum, which are open, public, permissionless, other types of blockchains exist, such as permission, private, closed, consortium, enterprise, and even the hybrids. And each blockchain can serve different purposes, obey different rules, and employ different protocols. Each blockchain has its advantages and disadvantages, of course. So that's going to be the gist of this live. There's a lot. There's a lot when you look to learn about blockchain itself and cryptocurrencies in general. I would say it's just a process that you have to always be interested in seeing what's new. Because there are new events that unfold in the world of blockchain technology. There are new heavy hitters in the game that pop up every other day. There are new ways at the enterprise level and at the regular at the commercial level and even at just the retail level, that things are popping up in the world of blockchain technology that allows us to integrate these systems into our everyday ways of life. NFTs is a big one. If you haven't checked into NFTs, I would suggest you check into NFTs on the on even on Meta, on Instagram right now, on Facebook also they're giving you the ability to actually use your NFTs and verify your NFTs. So you're able to post your NFT and it's verified as a digital collectible. Or you can post an item as an NFT and it will link that as an NFT. And you're able to actually click on it and go to OpenSea, which is one of the biggest NFT marketplaces. You're able to check out the NFT purchases if you want. They even implemented a feature to buy NFTs with credit cards, so you're not just having to buy them with cryptocurrencies, which is generally what most people do, because that has been the system that's been implemented. But of course, they're integrating it to be accessible by the common user. So yeah, there's a lot, but I mean, it's worth learning. It's the future and it's being integrated into your everyday systems. Most of the web applications that you're using right now or that you have access to are going to be using NFTs and blockchain technology in some way because of the value that it provides. And the internet is susceptible to advancement, just like every other industry. It advances things even faster, honestly. Take the time out learning about blockchain, learning about crypto. Expand your horizon. That's just my recommendation. A 10 out of 10 recommend. Hope everyone has a great day. Thank you everyone who tuned in. I hope I provided some value and educating you all on Ethereum, which is fun. And ciao, until next time.